Okay, so this video, we're going to focus on the relationship between gas pressure and some other factors, especially volume. All right, together these are known as the gas laws. We're not going to get into all of the gas laws and how they all relate with formulas, but there is one particular gas law you need to know, and that's the one for the relationship between pressure and volume. All right, so in order to illustrate that, I've got two images here. These are from something that was called the Red Bull Stratus jump, and it was Felix Baumgartner. He went up in a helium balloon up to this height, which I don't know if you can see that there. Let's zoom in on it. Just a little bit of history. This was recent, I believe it was about a year ago. 128,000 feet, basically almost 39,000 meters above the surface of the Earth, and then he jumped from there. Basically skydiving, and he had a parachute that he opened once he was close enough to the ground, but basically he was in free fall for several minutes, going an insanely fast. I believe he broke the speed of sound. Anyway, this was pretty cool. The reason I show you these pictures is to compare the size of the balloon. All right, notice the height here, about 21,000 meters. Look at the size of the balloon, right? And then over here at 39,000 meters, look at the size of the balloon. You can tell the difference, right? Compare. It's a lot bigger here than it is here. Why would that be? Well, basically because the pressure is a lot lower in the upper atmosphere, way up there, than it is here, closer to the surface. Dude! So as you can see, there is a relationship between pressure and volume, and the relationship is inverse. So as pressure goes down, volume goes up. So as the pressure way up in the atmosphere, like we saw in that picture of the balloon, the pressure way up there is much, much lower. There's much fewer air particles up there. There's less weight of air pushing down, and there's so much less air pressure up there. In fact, there's almost none. So the volume gets quite large. The summary of that looks like this. So pressure 1 times volume 1 equals pressure 2 times volume 2. All right, so what's that mean? Well, here we have situation number 1, basically some initial situation. And then here we've changed something. We're in a different situation. So the variables here have changed. But the point is that the product of these two, the pressure of the thing and the volume of the thing, the product of those has to stay constant. So just to write that over here, basically pressure times volume has to stay constant. All right, has to stay constant. So you can change things up, you can change the conditions, but the product of those two things has to be constant. All right, so this represents a situation, as we were just discussing, where you have some starting conditions, and then you change something about them, and then you want to calculate how the other thing changed. So say you send the balloon up into the atmosphere, right? Pressure goes down, and then you want to find out, say you know what the pressure is, then you could calculate what the volume is, which is going to go up. Okay? So basically, to sum up, if the pressure decreases, the volume will increase. Now, you have to assume that temperature stays constant because temperature also has an effect in any case. If you ignore the effects of temperature, then as pressure decreases, volume increases. All right, so what effect does temperature have on pressure or on volume? And we're not going to go into this in detail, but basically temperature has a direct relationship with both pressure and volume. So if you increase the temperature, either the pressure will increase or the volume will increase if the container is able to expand. Possibly both the pressure and the volume will increase. It all depends on the exact situation. But say you hold volume constant and increase the temperature, so you have a fixed volume container and you heat it up, then pressure has to increase. If you say you have a container that is able to move, like say get bigger, it's able to expand, like maybe a balloon or a movable piston or something in a container. Well, in that case, volume will increase, but the pressure will end up staying the same. Anyway, so that's the basic nutshell. Temperature is directly related to pressure. Temperature is related directly to volume. If temperature goes up, then pressure would go up if volume stays constant. If temperature goes up, then volume would go up if pressure stays constant. Okay? Cool. Example time. Alright, so we have this example. A weather balloon begins on the ground with a volume of 10 cubic meters. And we'll say the pressure at the ground is 100 kilopascals. That's typical atmospheric pressure, or pretty close to it, rounded off. Alright, pressure is usually measured in pascals, which we discussed previously. Alright, so this weather balloon then is released into the atmosphere. And then at some point later, say we have a pressure gauge on there, and it tells us that the pressure now at some altitude is 25 kilopascals. What is the new volume of the balloon? Well, we're going to use this formula. Alright, let's go do it over here. Use that formula over there. Change the color. Alright, so 100 kilopascals times 10 cubic meters has to be equal to 25 kilopascals times some new volume. Okay, need some more space. So using some algebra, really simply, volume is equal to 1,000 divided by 25. And if you do that in your calculator, you're going to end up with 40. So the new volume is going to be 40 cubic meters. Notice, right? 40. That's 4 times more than we started with. What do you notice about the pressure initially and the pressure at the end? Well, the initial pressure compared to the final pressure, it's 1/4. This is 1/4 of that. So then the volume is going to expand by 4 times. So this decreases by a factor of 4, this increases by a factor of 4. It's a direct relationship. Well, no, it's not a direct relationship. In fact, it's an inverse relationship. But it's exactly inverse. So that's what I meant when I said direct. It's a 1 for 1, a 2 for 2, a 4 for 4. So if you decrease the pressure by a factor of 4, you increase the volume by a factor of 4. The amount that one decreases by is the factor that the other one increases by. All right, so that's an inverse relationship, but it's exactly inverse. All right, cool. That's all for this video. Thanks for watching.